on a new iteration of my cloud atmosphere shader, and I've got something that I think is pretty good. There's still some work to be done, some probably optimization work. We need to figure out like the bare minimum number of steps we need for certain things. But this atmosphere shader, I like it a lot. And the reason I like it is because it does some things that I couldn't do before. So the main difference here is that I've unified the marching for clouds and atmosphere into one loop instead of two loops. Well, I mean, there's a density march and a light march, so it's actually two loops. But before it was four loops. I was rendering the atmosphere in one pass. I was taking whatever the resulting color from that and passing it into the cloud layer as the light color, which is a way to kind of hack it together, but it's not the real way that it works. So um, I think we can draw it maybe. Okay, so before I would calculate the atmosphere color at a given camera position, and then I would render some clouds, and I would provide the color that was right here, the user was seeing, as the input color to the clouds. And this works to kind of get your sunset colors in the clouds and everything, but it's not actually the way it works. Because what's actually happening is we're marching through the atmosphere at some interval. Doop, 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 doop. And on every one of these steps, we're checking like, oh, you need to scatter some light. And you need to absorb some light. We just goes into the trash can. And the cloud at this point, the light interacting with that cloud should be whatever the result of that step's light instead of the end result of the entire trace, which was causing some like artifacting, some visual issues that I really didn't like that I couldn't get rid of. Um, so what I've done is the atmosphere is all driven by scattering, and clouds are also driven by scattering. So why not march it all in one go? So I created a little adaptive planner that basically constructs a series of segments for me to march. Let's do this again. So we have a atmosphere shell, like a planet radius, and then we also have a cloud inner radius and a cloud outer radius. And this is the shell between which clouds are allowed to be rendered. So we basically construct a plan where we take our first intersection here and here, and we make a segment, and then we continue the ray, and we go here, stop, and we make a segment, and then we would go over to here, just pretend like that didn't intersect the planet, and we make a segment out of that, and then again here, make a segment, and here. So we can have up to 5 segments, max, 1 segment, 2 segment, 3 segment, 4 segment, 5 segment. And each one of these segments will tell if it's in the cloud layer or if it's in the atmosphere only layer. And then we loop through these segments and we do our march, but the cloud layers get extra steps because we want fidelity for the cloud layer, and we don't have the step budget to be able to effectively do that through the entire atmosphere. Um, so instead, we just get a lot of localized slices inside these cloud shell segments, and then the rest march at like a much coarser step size. It's also adaptive, whereas before my step sizes were predetermined and it was just however many steps it takes. Now we have an atmosphere steps and a cloud steps. And at the end of this plan, it sums up the total distance that we traveled through the cloud and the total distance that we traveled through the atmosphere. And then it divides those total distances by these number of steps. So for each ray, we will always get our number of cloud steps through the cloud layers, and we will always get our number of atmospheres, which allows us to be deterministic in like how many steps this thing's going to use. Now, that said, it's still expensive. I need to optimize it quite a bit. But what this lets us do is really cool. Um, you can see here that the clouds are actually casting shadows through the atmosphere all the way down to the surface of the planet. If we go down here, we can see, like, if I'm traveling around, the overall brightness is changing based on if the light is obscured by the cloud or not. And that is because we have actual attenuation of the light propagating through the atmosphere based on like what it has already passed through. And we have controls for all of this stuff. I'm still working on the cloud density sampling. I really wanted to get all the scattering stuff to my satisfaction before I tried to dive down making the clouds themselves look better. And also, I don't have a planet here. It's just a hollow shell. We're just letting it go to the minimum radius of the planet and then cutting it off. But like normally this would be cut off by a depth check. We also do a depth check in here that will short circuit any rays that would hit an object. Um, there's another issue I had with my other shader is that I couldn't get actual full opacity. And now I can. So before, like, luminous objects would always shine through the clouds. But now you can see that when we're in the areas of very dense clouds, the sun is actually being completely obscured. Let's see. Like here, it's being completely obscured because we have a really dense cloud. Likewise, even on the night side of the planet, the clouds are obscuring the stars, which they were not doing before. So yeah, this set of changes, it allowed me to get full opacity on clouds or the atmosphere if we tune the settings high enough. Like if we hit this up to like, I don't know, 90. Yeah, we get more opacity, right? So we'll go back down to 9. Um, we have control over every set of scattering coefficients. We have control over extinction, so like, or absorption. So like here's cloud absorption. If I were to put this up to 100, we would get darker clouds that absorb more light faster. Ooh, it's chugging though. Oh, my dog just unplugged my computer. That's why. Okay. No plug-in, no graphics card. But now you can see that our clouds get darker much faster because they're absorbing light faster. Um, and we also get more God rays because more light is being absorbed by the clouds. The God rays is another thing that we could not get before due to the fact that our clouds and atmosphere were not interactive with each other. So let's try like a 50 here and come over here and we'll set our floor to 0. And this will give us complete cloud cover. So we just have a shell of clouds. Now, what if we go under the clouds? Now, we get what it would look like to have near complete cloud cover. And you could turn this up if you wanted to like have storms occur or something like that. But also, we're getting God rays through the thinner parts of the clouds. And that's because everything is working as physics dictates that it should. So the light is being absorbed by the clouds. The higher our absorption, the more dramatic that will be. So if we go back here again, for instance, Now we have very dramatic God rays in the thin parts because our clouds are so absorptive that so yeah, you're just cruising around beneath like a really dense cloud layer. So like for storm clouds and the like, you could potentially crank the absorption up and the clouds get darker. We also have full opacity while we're inside of the clouds, assuming we're in a dense enough part of them, which was another thing that I had issues with before. So yeah, this just solves like basically all the pain points I had with my old shader. Um, it still needs a little bit of TLC, code cleanup, things like that. But this is a pretty sick little piece of HLSL. Eventually, this will go up to my GitHub. I'm not done with it yet, so it still needs a little bit more work. But we still have, like physics-based scattering. So I save this. I'm just like, I'm just fiddling with like the cloud density stuff right now. But yeah, I've been working on this for like the past weekend or so, past couple weekends, and just kind of plugging away, trying to get this to my satisfaction. As of last night, I finally kind of got the scattering working. So today I started adding the like cloud density to like actually like cookie cutter out the clouds from the cloud layer. Um, so that still needs a bit of work, but you can see that we have different colors of sky at different times of day based on what angle you're looking at, how much material the light ray is passing through before it gets to you. Um, we can mess around with scattering coefficients for everything and absorption coefficients for everything in all three channels, which is really cool. So it gives us the option to say, okay, what if on an alien world the clouds absorbed more blue light than red and green light? Well, now the light that makes it through the cloud is yellower because we're absorbing out more of the blue. Let's do more green than blue and red. Now the light coming through the clouds is pink, even though on the outside, and our darker parts of the cloud are taking that pink tinge, but our outer portion of the clouds are still scattering white light. So again, what if the outer portion of the clouds scattered more blue light? Then it looks like this. Or, for example, more red light. So we can mess with the scattering properties of all of our stuff. We can get different cloud effects, different absorption effects. We also have atmospheric absorption parameters, atmospheric scattering parameters. We can change the overall scattering parameters of the entire atmosphere here. Now you have a green sunlight with a purple sunset. Or we can go back to a more like Earth-like or even like almost tropical color. And this is going to have more pinkish, orangish, reddish sunsets. And this is all just physics driven, based on physics, but like you would never have, for example, you would be unlikely to have like a red sky because of the way scattering works. But we can have that because we have full control over the whole gamut of the scattering here. Flip this back, crank this up to 9. So I'm kind of looking for defaults that look Earth-like, and kind of getting a baseline of like what are my parameters going to look like. Everything goes out like the fidelity goes out the window when you're inside the planet, but you should never be inside the planet. So um, it's just kind of short circuiting a lot of the logic that would cause it to have issues. Um, let's see. What are the other features here? We can control atmosphere absorption. We have control over the light steps and steps. So, like I said, these are deterministic now. You will always get this number of steps. So right now I have it on 32 atmosphere steps. This could probably come down to like 16, most likely. Jake, hey, no. Hey! Uh-uh. No. No. Don't do that. You turd. Yeah, we could probably come down to like 16. It's all gonna be. And now he unplugs my computer by. Are you spiting me? Are you ever spiting me? You little turd. Are you mad because you wanted to chew up a piece of the vacuum cleaner and I took it from you? All right, plugging my computer back in. Hang on. We have night sky. We have day side. But yeah, this is pretty cool. It is a work in progress. Okay, that's too high for me. Height. It does require a little bit of fiddling here. Maybe 0.5 is good enough. Yeah, that's pretty good. Um, what else? What else? What else? What's absorption height, absorption height, fall off, absorption beta, cloud ambient. We have the ambient light of the clouds, so we can control if how dark they're gonna get, even on the dark. Like, what is their minimum color, basically? And this would let you see them in like the night sky. You would still be able to tell that there's a cloud there, not just like an empty patch of stars. But yeah, I'm pretty happy with this. Atmosphere steps 16, atmosphere light steps 6, 8 maybe, and then cloud light steps 16. And now I'm just kind of in the process of polishing and optimizing, and I need to like get a weather system in place to like pick out, or not a weather system yet, but like a more less naive cloud distribution system, cloud density sampler. But that's just a noise based thing. Like, that's all fun to play with. All the scattering and stuff that actually is the heart and soul of like why this works the way it does are all in place now, which is quite cool. I do wish that I could figure out a way that to get rid of the blue noise banding. I wonder if I could jitter it, or if I could alter the blue noise sample based on the time. Yeah, if I did that, then the temporal aliasing might take care of it. Let's see if we can blur this puppy. So we will come up here, go here, go here, time. Fine. So my own temporal anti-aliasing. Aha. I think there's something to be said for this. I'm just not sure what. It is probably better with the temporal jitter. Also, I will point out that because all of this is integrated, our clouds are getting the correct scattering on the sunset side. They're getting the correct scattering on the daytime side. All of the colors are appropriate for the position that you're at and viewing the clouds from. This puppy is being so frustrating. Dude, stop. Stop being a turd. Jake. What the hell are you doing back there? Okay, I gotta deal with this puppy. Hang on, hang on. Oh my god. Jake, get out of there. Come. 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 You little turd. Jake, come here, you little turd. I swear to God. Jake, come. 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 Get in here. Turd. This puppy is driving me crazy. Yeah, so haven't been doing a ton of streams or videos. We did adopt a puppy. He is a pain in my ass, but he's a good boy too. He's a good boy too. He's just a little bit extra. All right. So the main thing I wanted to do was just demo this because I'm kind of in a tinkering with it state right now. Um, where I have a few things that need to be fixed. Like there's still some banding here that I would like to figure out if I can do something about it. I do think the temporal jitter is good here. I wonder. Wonder if we could integrate that internally, because we do a couple for the light march. We also do a jitter, but it's hash based. Let's actually restore our absorption to like 30, which is closer to reality. The temporal anti-aliasing causes the issue that I had with the other one where it's off center, and I don't remember how I fixed that. I mean, it's better than just it being statically grainy. And if I'm varying that like we're doing here, let's clean all this shit up. If I'm varying that, we do pass in this value. We could just integrate that value into the main march's calculation of the light offset. Oh, it already is. Hmm. I guess that's okay then. I may need to increase the time frequency. as I can tell, this is having zero impact. Make float 2. And add that instead. Sine and the cosine. It's got this horizontal jitter trying to get rid of. Yeah, that's kind of useful. Right, and here it was with no variance. Well, I don't know. It might actually be better like this. We could also try a different blue noise. Hmm. And then the other thing we could do potentially would be to sample it inside the function, not based on the screen UV. I do pixel position. What's that do? Wait, is that not just like way, way better? No, but now I have the slicing. Yeah. That's like if it didn't have it at all, basically. Yeah, so we have the slicing there, which is what this is meant to combat. Yeah, and anything past that is pretty much out. Maybe we just learn to love the static filter. Maybe we could do that. Yeah, so, I mean, I don't think it needs to be this. We can go back to our original blue noise. We can go back to using the R channel. I am kind of curious as to what would happen if I plug this into here. That's kind of interesting. I think just having it static in there is probably going to end up being the way, even if we get some jankiness. You also get these nice shadows through the atmosphere from the clouds now that I wasn't getting before. It's pretty cool. Nighttime clouds that are actually opaque, which you couldn't do before. I was compositing the scene color wrong, is the reason why. Um, Wish I could get rid of that kind of slicing effect that it's having. It looks good when you're static in any position, but when you fly, you will occasionally see some slices that I'm not super fond of. Um, let's mess around with step sizes. Okay, atmosphere light steps. 16. 30, 21. This kind of behavior here is what I'm talking about. Okay, so that did not seem to have an impact there. Yeah, it's the same pulse rate. 32. The problem is that like increasing our steps does increase our quality and decreases like that flickering, but it also slows it down a lot. Makes it way more expensive. Could I possibly reduce this one? Okay, that's not too bad. Um, Cloud light steps. How low can we go with this and still have it look okay? Looks pretty good to me. Mm-hmm. 12, 8, 12, 2, 12, 32, 8, 9, 10, 8, 6, 5, 4, 3. Seems like after 8, we're only seeing like marginal. Every step we can cut off the light steps is dramatically better performance for us. Like if I can get away with 4 and 8, then that would be great because that would mean we can increase these without really any cost, which is just going to be pure increased fidelity. Yeah, now we're talking. I mean, it does have a cost, but like this is outer loop and these are inner loop. So increasing the outer loop is a lot less expensive than increasing the inner loop. $64 is too much. Let's run it like that. Oh yeah, now we're talking. Less flickering as well. Although we're still chugging at times. Yeah, I'm gonna have to figure out why. Why are you chugging? But yeah, so we're in optimization phases for this, and then I'll build an atmosphere blueprint. I think I'm going to include a directional light with, with the atmosphere blueprint so that when you spawn in a planet, it just automatically spawns in the light source. And since I have to define light data for this anyway, like in order to make this shader work, I have to tell the light direction and the atmosphere center, cloud radiuses, max radius of the atmosphere, max radius of the planet. But we also have a light setting here. So we could, for instance, change our incoming light color. Our atmosphere will continue to scatter the way it was, but a different light color would change the overall appearance. Um, and we can also change our light direction. But light color includes intensity in this case. So with just these two parameters, we already have all the information we would need to set up a directional light. I'm roughly correlating the magnitude of the light with the lumens. So 10 magnitude light, 10 lumen directional light. One 150. Huh? Let's. We'll go ahead and add a black body material here. Add our planet radius so that we can literally not go inside of it. And that'll let us get a better feel for like what sunset would look like. I feel like this is a pretty good looking sunset, to be honest. Um, Can I spawn in and walk on this by any chance? We can. This is obviously much smaller than an actual planet. I think I'm working in like a 1 kilometer scale. Like our planet is 1.5 kilometers, so you could circumnavigate it in, I don't know, 10 or 15 minutes of jogging. I want to at least experience a sunrise here. Oh, that's a problem. That's not even my code. That's the bloom. Actually, no, it might be my code. That might be the Mie scattering showing through. Would have to figure it out. At some point, we're going to fall off this thing. I don't have spherical gravity in this stage. Oh no, I guess I do have spherical gravity. Um, okay. Oh, okay, yeah, cause my spherical gravity in this project sucks. Actually, I have an entire gravity project that's gonna get integrated in here eventually. But yeah, yeah. So anyway, this is what I've been working on the past few days. Not gonna promise I'm gonna be streaming or anything on a regular basis because I'm dealing with a bunch of other shit, and I don't have time for it all the time. But I did. I was pretty happy with the results of this effort, so I wanted to make a quick demo of it. All right, later.